Hi, my name's Alan Champneys. I'm from the Department of Engineering and Mathematics, and I'd like to tell you about our degree programs. I've been in the department now for something like 26 years, and I've had many roles, and I've seen generations of students come and go, thrive on our program, and go on to do amazing things. So why choose engineering mathematics as a degree program? Our degree is certainly not engineering and mathematics. It's not a joint honours degree program. In fact, it's the only course of its kind in the UK. We find that not many people have heard of us, but when they do, students looking for degree programs, a considerable number choose to come on our program because we're unique. It's about applying mathematics to the real world. We have cutting edge courses informed by some of the leaders in research. Here you see three of my colleagues on the right here, Professor Jonathan Rossiter, Sabine Howard, and Nello Christianini, giving TED Talks or public lectures on aspects of artificial intelligence, robotics, and mathematical modelling. We also work with industry, as I'll explain. We're a small, friendly department that's existed in its teaching these degree programs for over 30 years. This year we're growing. We're looking for an intake of about 70 students, but there's a good staff-student ratio. And I'm going to tell you about internships and careers. There's also an excellent well-being support in the university. And the students like us. For the last 5 years, we've had over 90% satisfaction in the National Student Survey. And recently we were voted #1 in the Guardian League table in general engineering. So, what is engineering mathematics? Engineering maths, WTF. Put simply, it's the art of applying mathematics, or mathematical sciences in their broadest sense, including data, computing, etc., to complex real-world problems. It combines mathematics, practical engineering, and scientific computing, and it addresses many of today's technological challenges. Let me explain. You see, maths underpins engineering and societal challenge. It is the language by which we translate ideas in technology, the environment, medicine, into solutions. Here are a few things which I won't have time to tell you about, but technology is becoming smarter. We look at autonomous systems, the Internet of Things. How do we turn those into purposeful devices that can actually do good in society? Big data is all around us. It's important in our lives, from banking, advertising, healthcare, travel bookings. But how do we keep it safe, intelligent, secure, and transparent or explainable? These are maths questions. How do we process data so that we can understand what's going on? For example, the Google PageRank algorithm is based on a fundamental idea in so-called linear algebra with matrices. Climate models. We hear that scientists are doing big simulations of the climate. What are they doing? Well, they're solving massive sets of partial differential equations, but they're having to rectify those in real time against data. And that so-called Bayesian updating is a very modern idea in mathematics. Biology is becoming quantitative, just as physics and engineering did in the 19th century. So we specialize in the department, for example, in synthetic biology, in computational biology, and in so-called soft robotics. What's this interface between technology and the body? And Jonathan Rossiter, my colleague, has just won a massive grant from the UK government to build genuinely implantable robotic muscles. Intelligent transport. The notion of a single mode of transport is becoming blurred. One of my colleagues, Eddie Wilson, is a major player in this idea of intelligent transport systems. For example, if you look at autonomous vehicles, how can we come up with algorithms and ways in which they talk to each other that not only enables them to be safe with each other, but to enable them to be safe with humans? And smart grids is a massive mathematical challenge, because we have to understand how we put distributed energy generation onto a grid that's designed to be a synchronous top-down system with large power stations delivering power to all. How do you solve these questions? Well, it relies on a process, and that process we call mathematical and data modelling. MDM is something that you're taught throughout, or you engage in throughout the programme in all years. And the fundamental concept is this: you take a real world problem, you analyse it, interpret it, maybe look at it as a system or look at the data, create some kind of mathematical model, some paradigm or some equations for analyzing the data and the inputs and the outputs. You solve that model after making lots of simplifications and come up with a prediction, which in general is too simple. And so you have to come up with new assumptions as you get more data. And so this is an iterative process. There's no such thing in the real world as a right answer. There are just answers and better answers. And we use mathematics as a process to solve these technological challenges. So how does that translate into what we actually teach you? What is the degree program of engineering mathematics, and how does that turn you into this interdisciplinary problem solver? Well, yes, there's lots of maths. Not only do we teach engineering maths, discrete maths, mechanics, etc., but also some very advanced things that you don't get on most mathematics programs in the UK. For example, advanced ideas in nonlinear dynamics and chaos, in mathematical modelling in physiology, and in complex network theory. Yes, this is a general engineering program. In the first 2 years, you do course units with other engineers across the faculty in fluid mechanics, in control theory, in electronics, in thermodynamics, in mechanics, and then we specialise in various areas like robotics. Computers are important. We're not training you to be a software engineer, but everybody, coding is becoming a core skill that everybody should engage with. We also teach various application software such as MATLAB. We also specialise in AI and data science. We've had a professor of artificial intelligence in the department for over 30 years. And then, of course, we teach you how to do group work, how to do this mathematical modelling, as well as teaching you the professional skills such as project management, ethics and budgeting, etc., to apply this in the real world. And one of the great benefits, talking about the real world, of being embedded within an engineering faculty is we have our industrial liaison office, whose job is to link all engineering students with industrial experiences. They do that in many ways, but let me just highlight two. Every first year student in our program and across engineering, that's an industrial mentor who you meet at least 3 times, is probably going to be your first contact on LinkedIn if you don't already have one. And you get assessed on how you reflect on that as part of the professional studies teaching. There's also the opportunity to switch on to, you can't apply for it, but you can switch on to the Year in Industry scheme. And we're sending our first students this coming year into various companies who are sympathetic with the ethos of our degree. And one of my tutees is going to ACOM, a project management consultancy. There are several flavours of the degree. We recommend, because it has so much in it, that the 4-year programme is an accredited engineering degree. All programmes in engineering are 4 years straight. But you can come out with a bachelor's by doing a little bit less project work, fewer applications of the ideas. You can also do a study abroad, and we send students regularly to North America, to Australia, and to continental Europe, and this study in industry that I mentioned. Here's the standard offer, although there are contextual offers as well, and you become a chartered engineer or a chartered mathematician. It's your choice. But the best thing about our degree are our students. There is a fantastic team ethic. Because there are these group projects throughout the programme, the students get to know each other. A relatively small cohort compared to some of the larger cohorts in science and engineering. They get involved in lots of engineering societies. Have a look at the resources tab at the end of this presentation. And about 5 or 6 years ago, they formed the Bristol Engineering Maths Society, or BEMS, as it's now called. One of the most exciting events, the highlight of the year, is the summer formal. There's a picture of me in a bow tie about to give an embarrassing speech. They also have a pint of Eng Maths, which are early evening events where they get recent graduates to come back and tell you what it's like on the other side. And they have a buddying or parenting scheme. And our graduates are in demand. 95% are in work after 6 months after graduation, and most of them are using their degree. Our degree opens many doors because you become a quantitative problem solver in consultancy. Some go into entrepreneurial activity, in general engineering, in government agencies, IT and data, and many get this buzzing through. Here's just a summary of why to choose our degree again. We're unique, small and friendly, students are satisfied, and we're well recognised nationally and internationally. And finally, do find out more. Come and join our online chat now and look at the resources page, bookmark our webpage and follow us on Twitter. and we look forward to seeing you in 2021. Please do come and join the chat now to ask whatever questions you have of my colleagues or our students. Thank you very much.